My name is Matt Palmer. There's a little bit about me here. So I've been the lead scientist for sea level research at the Met Office Hadley Centre. So that's the part of the Met Office that deals with climate change. I've been doing that job for the last 10 years. A couple of years ago, I got a position as associate professor at the University of Bristol. So a lot of my research now is done at that institute. And I was also a lead author on the latest United Nations climate report. So hopefully some of you might be familiar with the Intergovernmental Panel on Climate Change, but they really represent the international scientific consensus on climate change. So this is the body that is charged with giving the scientific information that informs the international climate negotiations that take place at, for example, COP26 in Glasgow a couple of years ago, and there's another a Conference of Parties meeting. So. Okay, I wanted to throw in, so what I've been doing the last couple of days is actually staying just down in Crackenden Haven and surfing. So Bude is somewhere I've known for a long time. I've been coming here for about 20 years, usually surfing at Widemouth Bay, but I just wanted to let you know that I have a personal connection to this part of the world. So I'm going to talk about sea level rise. First of all, I'm going to talk about what we've observed, so what's happened in the past, and I'm then going to talk about what we think is going to happen in the future. So what we've got here is a plot. So this is the kind of work that I do a lot on, but this axis is giving you the sea level rise in centimeters. And then I've got two lines. So this is time going from 1900 back here all the way up to about 2020. And then I've got global sea level. So this is global average sea level. And you can see that since 1900, sea level's risen globally by about 20 centimeters. So what's that? I don't know, about that much. We can see that if we take a tide gauge record, so these are the local observations we have of sea level down in Newlyn, we can see actually we get a pretty consistent rise over time. So we've had about 20 centimeters or so at Newlyn as well, but with a few more wiggles on the line. So there's a bit more year-to-year variability, but the trend is very clear. Okay, so we've had about 20 centimeters rise since 1900. So a very short bit on the science. There are the two most important contributions to global sea level rise are the fact that the oceans are warming under climate change. So the seawater expands as it gets warm. It's exactly the same principle that makes a thermometer work. And the other thing that happens is that land-based ice gets added to the ocean. So we can think of this as water being added to the ocean. So there's the filling the bath coming from the melting of ice, and there's the water in the bath kind of expanding because it's getting hotter, it's getting heated. And we'll find, so these two processes have had about an equal share of the observed sea level rise, but the real threat for future sea level rise is this extra water being added to the system from the melting of land-based ice, particularly with the ice sheets that are near the poles of the Earth. So there's the Greenland ice sheet in the north, and there's the Antarctic ice sheet in the south, and we'll return to that. So this is some more line plots. Hopefully they make sense to you, but these are now showing us what sea level rise is projected to do over the 21st century. So this timeline now ending in 2100. I've put the same Newlyn observations here that we had before for scale, so you can see roughly how they compare. But essentially, so this red area here is giving us a projection of sea level rise under a high warming world. So this is a world where there's intensive burning of fossil fuels and increasing greenhouse gas emissions, with essentially nothing done to reduce those greenhouse gas emissions. This low warming world in blue is a future in which we are very effective in bringing down greenhouse gas emissions and limiting the future warming. So you can see that sea level rise continues in both of these situations, but obviously it's a much higher degree of sea level rise under a warming climate. So the top here is about 1.2 meters, and these areas here What we're trying to do with these areas is to characterize the most likely outcomes, but we can't tell you where in this range the future sea level rise will occur. So we have to be prepared for one way of thinking about it is it's wise to prepare for the upper end of these shaded bands rather than gambling on us getting lucky and ending up down near the bottom of these shaded bands. So that's sea level rise for Newlyn. The sea level rise for Bude is quite close by in relative terms, and we get a little bit less sea level rise at Bude, but essentially the two plots are very similar. So that's out to 2100. So I've made this point: the sea level rise will not stop at 2100. We can see it still going up. So there are ways that we can extend these projections to 2300. So this is a really long time in the future. We're talking about over 200 years in the future. But you can see that even at that stage, there is still some rise. Under this low warming scenario, then it's possible we can stabilize sea level. And these numbers become very large. So we're up into many meters of sea level rise. And of course, at these long time scales, it's much less certain, meaning that there's a really wide range of possible outcomes depending on what happens. So the key point is sea level rise will continue to happen, and the amount of that sea level rise is strongly dependent on the future warming level. So I'm going to use the units of a London bus to kind of illustrate some of these numbers. So under a low warming, we could still see up to about 2 meters of sea level rise, even under a low warming future. Now, this is a long time in the future, 2300. If we follow a high warming future, then we're kind of risking up to 4 meters of sea level rise. But there's another key thing that we need to know about, and this is the uncertainty that we have, the scientific uncertainty around how the Antarctic ice sheet will respond under global warming. So there are poorly understood scientific processes that we know about, but we find very hard to quantify, that could lead to much faster rate of sea level rise. And this is basically about solid ice that's sitting on the land being released into the ocean very quickly. And so the latest UN climate change report kind of said that, so I've told you so far about where we think the sea level is headed, but this is some extra information telling us about a risk that we cannot rule out scientifically under high emissions. So under a high warming world, we cannot rule out the possibility of getting for the purposes of this, let's just say about 5 meters by 2150. And then that number becomes very, very large at 2300. So there's this real increase in the speed at which sea level can rise under this scenario. Okay, so I'm right at the end now. Cool, yes. So I think there's three things that, I thought about what are the three messages I'd really like you to take away from this. So the first one is, sea level rise will not stop at 2100. And even under a low warming future, we could see 2 meters of rise by 2300. So I'm not an expert in adaptation planning or coastal management, but from my standpoint as a scientist, it seems like coastal defense managers or coastal decision makers need to be thinking about this 2 meters number, because that's where we're going to end. That's the amount that we definitely want to be prepared for, at least understand what we would do in that eventuality. So the second point is that uncertainties in the response of Antarctica means that we cannot rule out about 5 meters by 2150 and more than 15 meters by 2300 under high warming. So this is an area of science that we're still finding out about, and I would hope that we'll be able to get a better handle on this risk in the years that follow. But right now, this is the state of the science. We cannot rule out these much larger numbers. I guess the good news is that we have time, right? We have a bit of time to think about this and even observe how the system changes over the coming decades. Okay, and I guess this is the most important bit in some ways. So the best way, how do we limit the risk? How do we limit the future sea level rise that we're going to see? And the answer to that is through, really, we need to get the coordinated global efforts to eliminate the use of fossil fuels and bring down greenhouse gas emissions as quickly as possible. So the cooler we keep the planet, the less risk we have of these Antarctic ice sheet processes rapidly accelerating sea level rise. So that's all I have to say. Thanks for your attention.